My name is Gáspár Nagy, and I started my career as a software developer. And after a while, I moved more from developing software to develop software developers, so become a kind of developer coach. And so I was supporting teams, and supporting teams can mean a lot of things. And 7 years ago, my team has realized that they need better tool support for improving their testing and to be able to practice behavior-driven development. So I really felt that I need to support my team, so I just put together a small tool called SpecFlow that afterwards became open source and become quite a popular tool in the .NET space. So this is actually the official .NET port of Cucumber now. So it's used by like 20, 30,000 people, more people that I ever talked to. Or if, for example, everyone would buy me a beer, then I think I would have enough beer for the rest of my life. So this was a huge impact in my life, and it was a huge impact in my career. So I suddenly realized that there is a lot of interesting thing in testing and interesting thing in agile testing. So I started to deal more and more with this. And the ratio of my slides are quite funny. And I suddenly become a kind of BDD addict. And nowadays I work as an independent trainer or coach. And I'm trying to help teams like yours to have better testing and better test automation in the BDD space. So we are talking about BDD, and actually it's pretty easy to follow Stefan from this perspective because he has already gave you a little bit of introduction to BDD, and actually he has asked you to, if you have seen BDD at all. Now my question should be that, is there anyone who was not here in Stefan's presentation? Okay, so basically you have I have the same audience. So let me just give my intro, my take on what BDD is. And whenever I say BDD, of course, this means behavior-driven development. This is the abbreviation for that. But actually, whenever you have heard specification by example or acceptance test-driven development, they are more or less the same. Of course, there are slight differences, but at least in our level where we are, we can say that these are about the same techniques. So it's not so. I mean, Stefan also said that it's pretty easy to understand the BDD, but it's not so easy to explain what BDD is. So this is my take. Let's look at a classic, of course, an oversimplified classic development process, an agile development process, where you start with a user story. And so you have a user story, you discuss it, you discuss the details of that, and you finally implement some source code, which is hopefully the right implementation of that requirement. And if you look at that source code to be able to figure out whether it's really the right implementation of that requirement, it's pretty hard to see. Not only because the letters are pretty small, but because there are maybe too many curly braces or cryptic structures in there. So what you do normally, you just run your application and see whether it really fulfills the requirement of the business. Now, by having the application running, you can get the feedback from the application. And this is how we work usually. And on the other hand, there are some problems in that. The implementation flow, so how we are implementing the software based on these discussions and based on the user story is pretty much uncontrolled. So how to capture the details in a proper way. And also the feedback is not so easy to see, and it's sometimes it's simply too slow, even in the terms of a 2-week sprint or something like that. So instead of that, in BDD, we still want to have the same goal. So we want to implement an application based on a user story. However, instead of just discussing the details and start implementing that, we are just trying to understand these requirements through some examples. Okay, so we are trying to understand the requirements through examples. And these examples are something which we are trying to capture as these Gherkin scenarios or BDD scenarios that are using these given, when, then keywords. So just an example. Given there is a conference with more than 400 people in there, and everyone is using their device actively, whenever I click on the green button, I want to have my slides advanced, right? So this is a concrete example about how such a clicker should work. Once you are discussing these examples, by having these discussions and trying to understand the requirements better, you can clear up a lot of misunderstandings. So basically, there is already a feedback to the business. Is this example really representative? Is this really describing what we wanted to have? There is a collaboration in there. Another thing is that since these examples are formulated with this Gherkin style, it's a semi-formulated English text, so to say, we can turn these into automatable acceptance tests. So basically, we can just run these scenarios, run these examples against our application that we are implementing, or rather, trying to implement our application driven by these examples, and we can have an immediate feedback for that. And this is where the tools like SpecFlow or Cucumber come into the picture. So basically, you can see that BDD has two parts. One is the collaboration aspect, where you are discussing these examples, and there is the tool aspect when you are taking these examples formulated in Gherkin, Given, When, Dance, and trying to run your application or develop your application through that, okay? Behavior-driven development, we are trying to drive this implementation with that. And if you hear about this, so driven or something like that, then you must remember, oh, there is the test-driven development, so this is something similar, right? How many of you know about TDD, test-driven development? Many of you, okay, super. So this means that you are more or less familiar how the test-driven development cycle works. You just take a failing test, right? You are trying to implement your application to fulfill this test, to make this test passing, and then you probably do some kind of cleanup. You are just cleaning up your desk that you can move on with the next failing test, make it pass, clean up, and this is the standard BDD cycle. This is how TDD works. And sometimes it's also called red-green refactor, if you like that better. OK, so this is nice, and you get now a clear picture that, oh, BDD is great. I can just use the scenarios, drive my development to that, and everything is fine. But wait a second. So what happens if we have a legacy application? And this is a question that I very often get. OK, this is all clear what you are saying, Gaspar, but we have a legacy application, how we can address this. And to be able to find some answer for that, it makes sense to try some metaphor, to try out what a legacy application means. And when I was thinking about that, I was feeling that maybe working with a legacy application is a little bit like renovating a house, right? Maybe this is not always true. Sometimes working with a legacy application is rather like trying to survive in a house that should be renovated. But let's be positive. So let's say that we want to improve this and we would like to renovate this house. So what you can see is that renovation can be sometimes challenging. I think my example, if you just see the number of hairs I left, this is a good example for that. So there are always some things that you cannot predict, and always some challenges that you cannot really foresee. So how you can apply BDD for that in this situation is pretty challenging as well. And let me tell you a story. Let me tell you my concrete story. I was thinking about what would be the best way to explain this thing to you, and I just thought that maybe it's the best if I just take a very, very, very concrete thing. So I also had a legacy application like this. It is the kind of legacy application which was a quite nice building at some point, like 10 or 20 years ago. It was modern at that time, but since then, many things has happened. Maybe there was no air conditions at that time. The elevators were not that smart yet. So the windows were quite, couldn't use the new engineering techniques and many other things. So maybe at some point it was a nice building, but now it's a little bit outdated, so we would like to renovate it a little bit. Clicker, yeah. So this was the same with my application. So it was having a kind of complex domain. This is just some rough structure of the domain model, or maybe the high-level domain model of the system. You don't need to understand that. It had also the other typical things that a legacy application that you just arrives to your mailbox or just got the assignment for has. So, for example, in my case, it had like a number of tests, but majority of them were failing, and even the failing ones were basically senseless. So I was just seeing there is some answer.is true, so okay, it probably has to be true, but it's false. But I don't know what this means, what this failure means. And of course, it also had some other interesting challenges like every legacy application had. So once I tried to set it up my local dev environment, I realized that the SQL Server Express is not able to import that database because that's so huge. So my first saying was that, OK, this is impossible to do the BDD with that. But after that, I calmed down and tried to think about it. OK, there must be a way of fixing this, and there must be a way of trying to apply some better practices even in this application. And for that, I tried to find a lot of interesting ideas from a book, which I definitely recommend if you are doing anything with legacy application. This is the Working with Legacy Code from Feathers. This is a very good book. It's not a very new one, but I think it's still very true. And I was trying to apply these practices in my own application. And finally, I realized that I would need to have a good metaphor. And the metaphor that I have found was what about trying to think about what scaffolding is for a house that you would like to renovate. And if you open up Wikipedia to see what is the definition of scaffolding, then it says that scaffolding is a temporary structure used to support the work crew or materials to aid in the construction, maintenance, and repair of buildings, bridges, or other man-made structures, like software. Right? So, this is for me. That's good. So how this could apply to my situation? And as I said, let me show you this through a very concrete example. And it's even that concrete that I was taking the commit messages, the individual commits on my Git history, and trying to make a slides out of that. So how I implemented my first change request in this legacy application that you have seen. For that, I have to a little bit introduce you to the topic of this application. So basically, this application is an application that is managing deployments of different software to some environments. Okay, so there are some softwares to be deployed. There are some scripts or workflow, how you can deploy it to a machine on your own environment. And basically, this software is maintaining this deployment process. And the first change request that I've got was the following. In order to test the deployment workflow, I would like to run these workflows even for non-frozen packages. So the typical workflow is that you have a package that you want to deploy, you freeze it, and then you can deploy it. However, if you want to just practice how this deployment script works, and you want to run it multiple times like a dry run, then it would make sense to be able to enable at least some special packages that you should be able to run this deployment workflow even for non-frozen packages, so that you don't have to restart the entire testing infrastructure again and again. And I was thinking about that, how to do that, and whenever I looked into my design diagram, I was seeing that, OK, this particular feature is somewhere down here. So it's a little bit of a small portion of my whole system that has to be changed, how the deployments and their workflows are somehow related to each other. So I was seeing that, OK, this means that there is upstairs, there is a window that I need to replace. There is upstairs a window that I need to fix somehow. How can I do that? And just like always, the first thing should be to check whether the infrastructure is ready, where you can really just prepare the environment, prepare the testing environment to be able to test things. So for me, every of such implementation typically starts with a scenario like this. Test scenario, when I do something. It doesn't check anything in the application. It's just basically I'm using this to verify whether I'm able to run a test, I'm able to run it in the CI build, and I'm able to exercise those core infrastructures that are used by my application. So if my application is using a database, then probably in this, when I do something, I just need to make a dummy query to the database just to see whether my infrastructure is working. If you think about that in the scaffolding metaphor, this means that you have all your tools or your things that are ready that you need to do for working with this scaffolding. The second thing is, OK, we are talking about a change request, so we are changing something. So that's very, very far. So it would be a very big jump to what we have currently. So instead of implementing the change request, or instead of making a test for that change request, I typically rather like to capture what is the current behavior, right? So actually, we wanted to change our system that you are able to run the workflows for non-frozen scenarios. So what is the current behavior is that you cannot right now run workflows for frozen scenarios, and I was capturing this in the following scenario. So cannot start deployment workflow with non-frozen deliverables. Even there is a package called test package for deliveries through MX and without expected deliverables, and there is a deployment for stage 1. If I attempt to start the workflow, and then this attempt should fail, and I should see an error message that, OK, it's an unfrozen package. This is how the system works right now. This is how the business has explained it to me, that this is how they have demoed it for me. And I was just writing it down into plain English without worrying too much. This is still very far from what, it's still a big jump, but I think this is just a discovery. This is what we have to understand, that let's try to discover more about our domain and try to address this in next steps. So we said that you would like to have, or in BDD, we usually make a kind of TDD cycle. So if you try to map this to the TDD cycle, we would need to make this into a failing test to be able to move on. So to be able to make this a failing test, first you should start trying to make it automated. So trying to automate this scenario, and to make a failing test that is a good starting point for you to implement things. It always makes sense to think about the then step. These are the ones where you are doing the verification. So typically, a good start for doing this is to start providing the automation code for the then steps. It doesn't matter exactly how the automation code looks like for this concrete example, but somehow first I created the automation infrastructure which was able to verify the then steps. Of course, the previous steps were not implemented so far, so this was a failure, or a failing test. But that was good because I'm already in the red phase, so I can just move on and try to implement the next steps. The next step would be the when step. So saying that when I attempt to start the workflow, and how I was demoing it and how I was trying it out with manual test, I was just trying to find an ID in the database, which is an unfrozen, which is deployment of an unfrozen package, and I was trying to run that for that. And this is the same what I was just basically hard-coded into this when step. So I just picked an ID from my database, which is completely stupid, right? And trying to start the workflow to see how it works, right? And once I did that, I've got the expected failure. So actually, I turned this test into a green one, which is already helping me to move forward with my TDD cycle. So now I have a test that passes. So I can just think about how I can move on and how I can make this nicer. And obviously, having this ID there is not really good. So this is something that I would like to get rid of. OK, so we've got some scaffolding, right? So we are just building up something which makes us to look around there and see what we can do. And let's try to get rid of this hardwired data. So I was just, again, looking into my diagram, my design diagram, and I've seen that this is the hardwired ID that you have seen in my test. So the only small task that I have to do is to get rid of that, which is basically implementing that first given step. Very easy. The small steps that you have to do is that first you have to create a system, that you have to add some components to that, a project, a delivery stream, an expected deliverables, a stage, a workflow, a package, a deliverable, and then I'm already there. Okay. At this point, I thought that, OK, I have two choices, that either I'm spending the rest of the year for implementing this single step, or just think about that, do I really want to get rid of the scaffolding right immediately after this step? Maybe I just need to just take down one piece of that, just remove a bit of this scaffolding, just to be able to have a better structure for making more new tests and improving this further. So instead of getting rid of this hardwire RDIF totally, what I did, I just made just a small step of that. So basically, I just elevated it into one level higher. So instead of hardwiring an ID here, actually what I did, I was just hardwiring an ID in a higher level and just made the last step automated. Okay, basically with this, because of the constraints of this application, just by making this small step enabled me much more thing than before. For example, I was able to rerun the test multiple times without to reset my database. So I was just making one step further to refactor my application and basically implemented these given steps based on that. So what you can see is that I was hardwiring a high-level ID to this system and moving the last part to automation. Still, I'm in the refactoring phase, so my test is still passing. And what I basically did, I was just finally be able to capture the current situation. So I have now a test which is capturing the current situation. And based on that, it's very easy to move forward to implement the real feature request that I need to do. I just need to make it, OK, this was the current situation. What should work differently from now on? And the details are not so interesting, but what you see here is that I was able to capture now the new feature that whenever this workflow ID is somewhere listed in a config file, and instead of having a failure, now it should succeed. And the good thing is that now we are getting back, even though that we are working in a legacy application, we got back into the TDD rhythm, and we are at a red test. So we can just go ahead and implement it like it would be a normal application and not like a legacy application. So yeah, just start kicking off this cycle and implement that. So basically, I was able to replace that window up there. And since I have the scaffolding, probably it makes sense to look around what happened with the other windows there. Maybe some of them are also need some repairment or at least some cleaning, which means in terms of our software that once we have some building blocks, once we have some automation blocks for implementing this new feature, maybe there's a couple of other scenarios, other features that we can already automate with this tool set that we have developed or with some further changes. So this is basically bootstrapping us to move on with the next step. As a summary of this, so what this concrete feature request implementation was telling me, or what process I was doing. So first I was ensuring that I have a working infrastructure. Then I was capturing the actual behavior, so how the system behaves right now. Then I was making it as a passing automated test. Based on that, it was much easier to express what is the new feature and then implement it and maybe also make a test coverage for all the other similar features that you have around. Of course, the same also would work with bugs as well. So you just capture the current behavior, trying to implement it, and so on. So what is the message of this? The message of this is that working with legacy applications maybe looks really hard, and it's very easy to say that, no, I cannot do this. I cannot do proper development. I cannot do clean code because it's a legacy application. But this is not true. You have to apply some systematic process and develop some systematic process how you approach things. And with really small steps and with some support, in this case, the support of a scaffolding, you can have some results. And if you look into a house which is fully scaffolded, it doesn't look beautiful, right? Scaffolding is ugly. But you know that at some point, this scaffolding will be teared down, and then you will have a nicely renovated house behind that. So the point is that it's absolutely valid to build up this scaffolding, absolutely valid to build up this supporting infrastructure. Once you know that you step by step will remove that, and finally we have a better maintainable legacy application. So have a maintenance, and I'm looking forward to your questions. Thank you very much.
Thank you very much, Mr. Nagy. So we still have time for some questions. Yes, the first question is arrived. How many teams are working together in your example?
In this particular example, or generally, of course, it's also depending case by case. So I think in this particular example that you have seen was a very small team. So we were like 2 developers and 1 tester who supported us. But actually, the same concept I have seen working with also bigger clients. I don't think that the size of the team is really really matters. It's more like whether you can, as a team, agree on some approach and really try to follow that. Of course, if everyone is doing some individual way of doing so, I try to do in a proper process and really try to make that test first passing before starting to jump into the implementation, and someone else is ignoring that. That's a bad team culture. That is basically killing all improvements and innovation in that. But regarding my experience, it doesn't really matter how big the team is. I mean, besides some normal agile limits like less than 10 people works fine. Yeah.
Any questions? Any more questions?
We have here.
Yes, we have here one.
I cannot answer, cannot put a question in written, so it's a little bit more difficult and more complex question. So you showed us a scaffolding one application, which is probably the easiest scenario, but consider a very complex development when you have multiple dependencies, multiple systems, and while you are scaffolding, right, probably you need to do it in multiple applications, multiple dependent projects. Do you have an advice on that, or what are the challenges there, and how would you solve it?
Mm-hmm. Thank you. So basically, there are two approaches for that. And it depends on how your dependencies can be managed. So if you can somehow make a cut of your dependencies, so maybe it's whatever, a relative simple REST API or some simple HTTP API to some external system, that's probably something which can be stopped somehow. So you can just cut off that external dependency and make it your own mock or something which is behaving how you expected that to behave. Depending on the technology you use, it's either easily possible or not. If it's not easily possible, basically this is also what I did here. So I was trying to just have a working test environment, which was used just by the manual testers before. So I didn't try to mock up anything in that first. I was just trying to get a working test environment and trying to run my test against that working test environment together with all the dependencies. If there were some manual tests before, this means that there must be some way of testing before. So actually, this infrastructure must be there. It's just not ideal yet for automated tests. And once you are progressing with that, and once you are having more and more stuff automated, and once you are trying to build up the infrastructure in a way that already thinking about that there will be a time when we can get rid of this subsystem, or we can get rid of the database or whatever else, then you can slowly tear that down and reach some better, more efficient structure. So there is no magic answer for that, but it's just that you have to really don't be afraid of making small steps, and just don't underestimate that these small steps are really leading you to somewhere at some point. So it's quite fantastic feeling that it looks like that it's a senseless test, and you just realize that you are just making 5 of that, and especially if you are trying to address an important functionality of your software, then you realize that, actually we have got a quite good coverage with that. So it works like that.
Okay, another question arrived. How to see or catch the point when renovation costs more? Or was this out of scope of your project?
No, I think this is an absolutely valid point. But the question is whether you want to, so let's say that your house is so bad that you need to bulldozer it and rebuild, right? But what happens if this house was some important architectural piece, right? And it was somehow protected by the culture. This means that you can tear it down and rebuild it, but you have to build at least the front end that looks like the same, right? You have to make pictures, you have to make some good measures of that it really looks like at the end how the old house was looking like. And this is the same what happens with software. There is some point where you say that the implementation of our application is so bad that it doesn't make sense to implement it further. However, whenever you decide to rebuild it, you want to reach the same feature richness, the same functionality that you had before. I was working with a little bit with the company who was having a software based on Flash, so the browser embedded Flash, and which looked like a very modern thing at some point. And however, after some time, they realized that Flash is untrendy, and sooner or later, every browser will disable that. So they need to rebuild their system on HTML5 or something like that. But how they can manage these transitions was a big challenge for them. And actually what they did, they were just capturing the behavior of their software with BDD scenarios on the Flash interface. And finally, they throw away the Flash stuff. And based on those scenarios, based on this specification that basically they have captured, they were able to rebuild it, supporting it in a more modern architecture. So these things are always related. So the costs might require you to rebuild the implementation, but the interface, so how the feature of your system probably needs to be remaining.